These are the frequently asked questions for pre-calculus for section 4.4, day 3. In exercises 57 to 60, it says construct a sinusoid with a given amplitude and period that goes through the given point. So for number 59, it says the amplitude is 1.5, and that's going to be our A value. And then they give us the period as pi over 6. Now, what that helps us figure out is what the value of b is, because 2 pi divided by the absolute value of b has to be pi over 6. We can do some really quick cross multiplying here and see that b has to be 12. So now we have another missing piece in our puzzle here. And then lastly, it says that this needs to go through the point 1, 0. So that means that when we put a 1 into this function, what we have to get is a 0 for an output. The way for us to get that would be to figure out the sine of 0 degrees, because the sine of 0 degrees is going to be a 0. So to make that happen, what we would want to do is put our input in there, and we would want to subtract 1. Because if we put a 1 into this function, 1 minus 1 is 0, and the sine of 0 degrees will give us 0 right back. So now we just need to put this all together in our y equals a sine of b times x minus h plus k formula. And you'll notice we don't have anything here that's dealing with k. So it will be y equals 1.5 times the sine of our b value was a 12. And then we said x minus 1 is how we're going to end up getting our 0 that we needed. And our k value is 0. So if we clean this up a little bit, I did see that the book just went ahead and left this instead of going ahead and distributing the 12. That's perfectly fine, especially if you're going to have to graph it. That's probably what you would want to do anyway. So we can certainly leave it just like that. Now, it wouldn't be a bad idea to distribute it either and finish it up that way. So this thinking is the same for number 60. So with number 60, we have an amplitude of 3.2, but this time our period is pi over 7. So 2 pi over the absolute value of b had to give us pi over 7. Well, cross multiplying, we're going to see that b has to be 14. And through the same thinking as the last one, we're definitely going to have x minus 5 in order to give us a sine of 0, which will end up with an output of 0. And that all because on the unit circle, a point out here at 0 is 1, 0, and remember this is cosine and this is sine. So that's the reason we want that to happen. So it'll be y equals a sine of b, and our x minus 5 to give us that output of 0, and then we don't have any vertical shift. So y equals 3.2 sine, and multiply it through or don't. The book didn't care which way you did it, but this would be 14x minus 7b. So this is constructing by meaning coming up with a formula that would give us what we need. Number 68. With this one, your questions were not about figuring out the phase shift, the vertical shift, and all of that good stuff, but let me just show you how we would break this up. And then we would figure out, everything that we need here. So our amplitude is going to be 2/3, which means we have a vertical shrink of 2/3 there. We also have 1/4 that's affecting the x there for our b value. So that is actually a horizontal stretch factor of 4. And then we see that we have a horizontal shift of 3 to the right and a vertical shift of 1 up. Now, this one, we don't see a pi in anything behind cosine. So the easiest way to graph this one would be graphing the parent function and then just move it. Use h and k like we always have in the past. So we would go 3 to the right and 1 up. So this is where it gets interesting when we don't see a pi anywhere in anything that we're doing. Then we just go back to the old figure out your parent function and then move it. So our graph, we want to figure out what that new period is. So 2 pi over the absolute value of b, in this case is 2 pi over 1/4, which will give us 8 pi. So that's our new period, and we want to separate that into fourths. So that would be 2 pi, 4 pi, 6 pi, and 8 pi, like so. And then again, we remember that we had to have this at 2/3. So maybe I would mark this as 1/3 and 2/3 and use it that way. All right, so like I said, what we want to do is we want to get a sketch of this graph, and then we're going to go ahead and move it. So we've got all of our pi's set up, and we have our intervals on here, and then we need to peek and see what it is we were supposed to graph, and this one is cosine. So for cosine, we start high, and in this case, a was 2/3, so we'd start up here, and then it is high axis, low axis, high. Oh, I really should make this one dashed. Let me go ahead and start making it dashed at this point, because remember, this is not our final product. This is just what we're going to move. So our final product here would come from the fact that we need to move this 3 to the right and 1 up. But we need to know what would 3 be in terms of pi. Well, obviously 3 is a little bit less than 1 pi. So we're not going to use this even one full interval to move that 3 to the right. And that's because everything that I have on my horizontal axis here is labeled in terms of pi. So we'll go almost 1 interval to the right, and then we will go 1 unit up. Now I did go by thirds. So I need to relabel 1 1/3 and 1 2/3 up here so that we don't mess up with that part. But again, because each one of these intervals is pi, we're not going to go quite 1 interval to the right, and then we have to make sure that we go 1 up. So at this point, we'd go over almost 1 interval to the right, and then we would go up to 1 2/3. And that puts us there. And we do the same thing for each one of these. And because we knew that this was going to be shifted 1 unit up, we can always go back and take a peek and make sure that we're looking symmetric. We're looking like we are cutting everything in half there, and we are. That amplitude, and you just continue that pattern. All right. Like I said, I think that's the easier way to do this one, rather than trying to make everything match when we don't have a pi available for use. Then we have number 73. And this one, I think if you draw a picture of what's going on, things get a lot easier. We've got a Ferris wheel. There's the center of the Ferris wheel. And we want to put on all the information that they have for us here. A Ferris wheel 50 feet in diameter makes 1 revolution every 40 seconds. So if it's 50 feet in diameter, it's 25 feet for its radius. And it said it makes 1 revolution for every 40 seconds. So that tells me it's going 2 pi every every 40 seconds. That sounds like something that's going to come in handy in a little bit. If the center of the wheel is 30 feet above the ground, all right, so this was 25 feet. This must be 5 feet right here. How long after reaching the low point is the rider 50 feet above the ground? All right, so let's take a look at what would happen if we roll out this Ferris wheel. So you get on the ride and you're down there at 5 feet above the ground. And obviously, you're going to go up. So we want to figure out how far up are we going to go. Well, we're 5 feet off the ground, and there's another 50 feet for the diameter, so that's going to take us to 55 feet. And that would be the highest you'll be able to go. And then, of course, you'll come back down to 5, etc. So when we look at this, we should be thinking, ooh, this would be a good one for cosine, because cosine is where you either start at a high or a low point. And this one is starting at a low point. So that would mean we're going to need to use a negative cosine for this graph, because cosine usually starts high and then goes down to the axis. So now we have a good start on what we need. So let's find everything that we need to make this work. All right, so one of the first things we had found in class was figuring out where's K. And K is going to be halfway between our 55 and our 5. So if we take 55 plus 5 and divide it by 2, that gives us 30. That's our K value. That's going to land right there in the middle. And while I'm there, I might as well figure out what A is. Because if this is 30, I think, well, how far does it take to get from 30 to 55? That's going to be 25. So my A here is going to be negative 25, because remember, we want to go from low up, cosine. And then I have to figure out, what on earth are we supposed to do for B? You know, what is the period? Well, that's right here. That's what this information was. And I might as well go ahead and simplify that a little bit and make that pi over 20. So we've got pi over 20, and then we think, all right, now what? Is this shifting right or left? No, 5 is the lowest point. So we could just use x here. I believe they wanted us to use this in terms of time, so we'll put t for time. Really wouldn't make any difference. So this is the equation that we need to have here, and it covers everything that we need. Now their question was, how long after reaching the low point is the rider going to be 50 feet above the ground? Well, 50 feet is h. Like so. And you could certainly graph it right at this point. I guess it kind of drove me nuts to see all of these numbers on here, so I simplified it a little first. I subtracted 30 from both sides. And then divided by negative 25. And this was a little bit easier to get into the calculator and make the window work really well. So y sub 1, y sub 2, I guess I did this backwards. I did y sub 2 for this and y sub 1 for this. So let's get that in here and take a peek. All right, y sub 1, we're going to use our cosine of, parentheses, pi, pi, there we go. Hopefully it'll replace it. It is not. It's being difficult. There we go. Pi divided by 20 x, because in this case we just need to have a variable in there. Doesn't matter whether or not we have t or not. And when we write it, because they wanted to talk about it in terms of pi, or in terms of time, t would be a better variable. So we've got the cosine of pi over 20 times x in there, and then we need the negative 4/5. And now the window. So what we need to do is think x is going to be time. So we'll put something in there just to try. I'll try 0 to 50 for time. This is seconds, and it's a Ferris wheel, and it's probably moving pretty fast. And then I already know what I want to see, and what I want to see is negative 4/5. So if I want negative 4/5, I could do something as small as negative 1 to 1, but I think I'm going to try negative 2 to 2. So there is the path of our Ferris wheel. And there's that negative 4/5. We want to know when did that happen. So that's going to be second trace, number 5. And I want Blinky to get over to the other intersection. So I'm going to use my arrow key to tell Blinky, you know what, over in this area. That's what I want. Oh, but it's stuck. Well, Blinky's still pretty good at this stuff. I'll let Blinky give it a try. So there we go, and there is our answer. 15.903 seconds gives us a negative 4/5, which is negative 0.8. So that is the answer that we wanted. The time would be approximately 15.903 seconds. 75. Ebb and flow. On a particular Labor Day, the high tide in Southern California occurs at 7:12 a.m. All right. 7:12 a.m. At that time, you measure the water, and it is 11 feet deep. So there's high tide. Gets me thinking this is going to be cosine, and that's because if we start with a high or a low, that's when we use cosine. You measure the water at 1:24 p.m. and you find out that it's 7 feet deep. Assume the depth of the water is a sinusoidal function of time with a period of 1/2 a lunar day. Well, there's the period information right there. And they're going to ask us a bunch of questions about this. Well, just like we did in class, the first thing we realize is we really need to switch this to military time, or we really need to think of this as just hours since midnight. Which, like I said, is kind of like military time. So 7:12 a.m. would be 7 12/60ths, and that is 7.2 hours since midnight. And then the 1:24 p.m. would be 1 24/60ths, which is 13.4 for our time. Now, we know this is high tide, we know this is low tide. So we get a little picture of what's going on here, just a sketch, so we can figure out this is not going to be too tough to get K. We just need to go halfway between that 7 and 11, which is of course 9. And then that tells us what A is, because to go from 9 to 11 or 9 to 7, you're looking at 2 feet. So our A value is going to be 2. Now, the period information they gave us was that it is 12 hours and 24 minutes. Well, we're going to have to convert that. So we'll take 12 plus 24/60ths to get that in hours. And that would give us 12.4. So now let's work backwards and find B. 2 pi over the absolute value of B will equal 12.4. So 2 pi will equal 12.4 times the absolute value of B. We need to go ahead and divide both sides by 12.4 to get B all by itself. And this is, of course, a perfect match for the example that we did in your notes. So B is pi over 6.2. Now, we have A, we have K, we have B. The last thing to do would be to see that if we start our cosine graph right here, that's going to require a shift, and that is a horizontal shift. And that horizontal shift is 7.2 to the right. So H is 7.2. So let's put this cosine business all together here. Y equals A cosine of B times x minus 7.2 plus 9. Well, there's a thing of beauty there, huh? Okay, so A says, at what time on that Labor Day does the first low tide occur? Well, we want to know when is the Y value at the lowest value, which is 7. So we want to know when is Y equal to 7. We're going to do that with the graphing calculator. We'll make this Y sub 1, we'll make this Y sub 2, and we'll figure that out. In fact, we need it for some of these other questions as well. So I'm going to punch this in and be right back. Punched in and ready to go. And what we wanted to figure out was when that first low tide occurred, and that was at 7. So I went into the window and I set this for a 24-hour period, so 0 to 24. And then I thought, if I'm looking at 7, I can do 6 to 12. That'll be just fine. And you could change that up a little bit. But we get a good look at the graph. And then what we're looking for is the intersection, and the first intersection with our red line down there. So Blinky's going to have to find his way all the way over there to the left. Hopefully this arrow key is not going to stick on me again and go crazy, but we'll see what happens. Because I want that leftmost intersection, and I've got to get Blinky to understand that by putting Blinky on the leftmost intersection. So there's enter, enter, enter to guess. And really, really close to 1 a.m. Very, very close to 1 a.m. All right. Part B, what was the approximate depth of the water at 4 a.m. and 9 p.m.? Well, I'm going to use my table feature for that. 4 a.m. is when x equals 4. And they also wanted to know about 9 p.m. Well, 9 p.m. would be 12 plus 9, because remember we did hours since midnight. So that's going to be x equals 21. So let's go see what the table has for us here at 4. And it looks like my table needs to be reset. All right, second table. So there's my first answer right up there at the top. 8.8987 is going to be the depth of the water at 4 a.m. And then I'm going to go into table set and just have it jump to 21 for me instead of sitting and hitting the arrow again and again. And at 21, 10.518. So at x equals 4, we had 8.899 feet, and at x equals 21, we had 10.518 feet. And last but not least, they have a question for us here that says, C is what is the first time on that Labor Day that the water is 9 feet deep? Well, we're going to go back in and make y sub 2 9 instead of 7, and we'll see when that first intersection occurs. So we regraph it, give the calculator a minute to reset to what it needs. Again, we're seeing the same cosine graph that we had before. But what we're looking for is a different intersection this time. We want that first time that the red hits the blue as it comes from the left-hand side. So second trace, number 5, and we're going to get Blinky over there again. Like I said before, I sure hope my left arrow doesn't stick. It's been doing that a lot lately. Let me give it some time to catch up. All right, now Blinky should be able to figure out that that is the intersection that I want. And we get 4.1. So a time of 4.1 is 4 1/10 of an hour. So that's going to be 4 a.m., but 1/10 of an hour is 6 minutes. So 4:06 a.m. And what they're really having us find here is when was the water halfway down, because that's what 9 was. It's halfway between that 7 and that 11. 84 says the graph of y equals f of x is a sinusoid with a period of 45 passing through the point 60. Which of the following can be determined from the given information? So we know from past experience that what we're really looking at is something that would need sine of x minus 6, and that's because 6 minus 6 would give you 0. The sine of 0 is 0. So we know we'd be able to figure this one out. Now, any possibility we could figure out the other ones? Well, only if they land at the exact same spot. And that has to do with the period. So I start thinking, 45, could I use that to get to 96? Well, putting 6 in here is what gives me 0. And if I use 2 full periods and then add that 6 on, that would give me 96. So I can actually figure out what this is if I can figure out what this is. And f of 6 would give us 0. But to figure out f of 0, I would need to know what a is. I would need to know what b is. I would need all that extra information. So these just happen to be the exact same position because we're really just moving at 2 full periods. So that means D is the only one that we would be able to figure out here. Number 86 says the number of solutions to the equation sine of 2000x equals 3/7 in the interval from 0 to 2 pi is what? Well, here's what I need to know. I would need to know how many solutions are going to be in each one of those cycles. And those cycles from 0 to 2 pi would give me 2 solutions to that. Here's how we know. You know, as we look at those quadrants, we're trying to figure out where we could get a positive 3/7 for sine. And that would be up here. So there should be 2 positions where we can get that 3/7. Now it's all about how many cycles will fit into that 2 pi. So that's where we say we need 2 pi over b, which is 2000. And that tells us in 2 pi, there are 2000 different cycles. So we have 2 for one cycle, but we have 2000 cycles, which means there will be 4000 of these, which is C. Number 89, visualizing a musical note. A piano tuner strikes a tuning fork for the note middle C and creates a sound wave that can be modeled by y equals 1.5 sine of 524 pi over t. And t is the time in seconds. So the first thing I was thinking of is this is b. You know, amplitude is going to be 1.5. That's great. But it takes a little work to figure out what we have for the periods. So we're going to take that 524 pi and figure out what that period is. And the pi's are going to cancel out, and our 2 over 524 will become 1 over 262. So that's our period. Now, B says, what's the frequency, which is F equals 1 over P? Well, if we take 1 and we divide it by 1 over 262, then that frequency is going to be 262. So this is 262 cycles per second. One part to this is finding those intervals. So what we have to do is take our period of 1 over 262, and we're going to multiply that by 1/4 so we can break this apart. Now our graph is going to start at 0, and 1/4 of 262 just happens to be a really obnoxious 1 over 1048. So these are going to be the first 2 points that we will be putting. Get the box out of that one so you don't get confused by that. We will be putting those on our x-axis. Doesn't that look like fun? All right. Then we'd add another 1 over 1048, and that will give us, in reduced form, 1 over 524. Then we'll keep adding that 1 over 1,048, and that will give us 3 over 1,048. And then we need to add another 1 over 1,048, which would be 4 over 1,048, but that reduces to 1 over 262, which is our full period. So what we see in the boxes, I should say in the green boxes there, are the points that we need for our interval. And you know, they're nasty, but that's what we have, so that's what we're going to use. So this is going to be 0. Let's see, can I fit these on here? Probably every 2 or so. I can fit these big fractions on here. So it's all about finding those critical points, which is what these are. These are the critical points that need to be on that horizontal axis. Okay, now let's go back and find A again. Well, A, many moons ago, they showed us was 1.5. So we're going to need to go up and down 1.5. All right, so let's get graphing. This is a sine graph, and sine is going to start at 0. Sahala, sine, axis, then high, up to 1.5 there, then axis, then low, down to negative 1.5, and axis. And there it is. There's our lovely graph that we would need for part C. That is it.